Let's begin our session. Begin with ASSET is an American Society of Science, Engineering and Technology. We welcome students from all the corners of the world to participate in a course, which we are calling this course as an Artificial Intelligence in a Modern Agriculture, where the future of smart farming begins. Under this series of ASSET Bioinformatic Workshop 2026. I am Sumaya Sanober. I have done my Ph.D. in Neural Network. I am one of the Asset Technology Committee member teaching at Old Dominion University in Department of Computer Science, Norfolk, Virginia, United States. And I will be your asset instructor for today as well as for this workshop series. An asset also presents on social media, including YouTube, LinkedIn, Instagram, and Facebook. So for that, you need to visit the asset website in order to get the information of these handles of YouTube, LinkedIn, Instagram, and Facebook. And adding to that, for this particular series or the workshops, what we are talking about, we have 6 weeks. And in the week 7, we have a session called as a quiz session where we will be having a quizzes for all the 6 weeks what you have been learned. And the good news is we have a cash prizes of some $100, $75, $50, $40, and $25 respectively for the first 5 winners, quiz winners. And also there will be a certificate that is being provided to you after you complete this workshop series, where you can list that in your CV, in your resume, or anywhere where you wanted to highlight that you have done this particular workshop for 6 or 7 weeks. Okay. And there is one important announcement for this workshop is student must attend all of these 6-week sessions in order to participate in the quiz, that is week 7, and also to obtain the certificate. Then we have a same session that is a repeated session by Dr. Abdul Wasi Muhammad, and he's going to repeat the session on July 18. If for some reason you're not able to attend or your friends are not able to attend, do let them know that this session is going to be on a repeat by Dr. Abdul Wasi Muhammad. He's going to do it on July 18th, 2026. That's on Saturday. Okay, so without any further delay, let me start with the slides. I hope you all can see my slides. These slides are already available on the website, and I hope you have these slides downloaded and ready. So let me begin with the slide 1. That's talking about the workshop that we are going to create. Okay. So as I told you that my name is Sumaya Sanober, and over the next 6 weeks, we are going to explore one of the fastest growing area in technology, that is artificial intelligence in modern agriculture. When many people heard about the word agriculture, the image that comes into mind is all about farm, tractors, and also people harvesting crops. And when we talk about artificial intelligence, the images that came to our mind is all about ChatGPT, robots, self-driving cars. Now, in today's workshop and in this entire series, we are trying to see how these two worlds are deeply connected to each other. The modern farms are becoming a technology hub where the farmer today uses a drone, satellites, robots, sensors, and buried underground, where the cloud computing, machine learning, and computer vision grows food for more efficiently than ever before. So this workshop is not only about farming, it is also about solving a global problem using technology. Whether you are interested in computer science, data science, electrical engineering, biology, environmental science, robotics, bioinformatics, you will see how these fields are contributing to feeding our world, or in terms of, I can say, farming. Moving on to the next slide, over the next 6 weeks, we will focus on 4 major learning objectives. First, we will learn about the IoT sensors in drone, where these technologies continuously collecting information such as soil moisture, temperature, humidity, and crop health. And second, we are going to learn about AI transformers, where this data or I can say where the AI transformed the data into a meaningful decision instead of farmers relying solely on their experience. AI will help determine the best time to irrigate, facilitate, or I can say fertile or identify plant disease. Third, we will discuss about the sustainability, where agriculture is not only about producing more food, it's also about producing food that will conserving the water, reducing chemicals, and protecting the environment. Finally, we will explore the career options that are within agriculture today needs an AI engineer, data scientist, robotic engineering, or I can say robotic engineers, drone specialists, bioinformaticians, and also software developers. So these are few of the what I can say career options that you can pursue if you are really interested in terms of agriculture or a smart farming or integrating or embedding AI into smart farming. Now let's understand why agriculture need all these technologies. Moving on to our third slide, let's begin asking a very simple questions. Why can't the farmers continuing farming in the same way we have done from centuries? What is the need of having an smart farming, or why do we need an AI?
I think smart farming makes agriculture more productive, sustainable, and profitable.
Yes, absolutely. Yes. Thank you. I really appreciate those answers. Adding to that, I would say that the answer lie for my question in the slides that you can see. By the year 2050, the world's population is expected to reach around 9.7 billion people. That means the agriculture will not only produce about 50% more food than it does today. So we need to produce more food that we are producing right now, more than 50% of that, because that's what an expected population of the world is going to reach. So, however, one of the another major challenges that we have is our agricultural land is shrinking due to urbanization, due to soil degradation and climate changes. So, more than 60% of human induced land degradation already affected the agricultural soil. So, we are going with the two major problems. On the one hand, we need to produce more food, more than 50% what we are producing right now. And the second challenge is because of, I can say, the urbanization, soil degradation, and climate changes, our land is shrinking. So this creates a challenge where we need to produce a significant amount of food while having a very fewer natural resources. So instead of expanding our farmland, we must be more smarter to use whatever land we have or whatever land we are using it in a more efficient way. And that's how AI comes into a picture, and that's how AI become extremely valuable that allow farmers to monitor every section of a field, detect problem early, reduce waste and maximizing the production. Instead of we are treating an entire farm in the same way, AI enabled to have a very precision agriculture. Right, naturally, we will say that yes, we wanted to improve the efficiency of the current land instead of purchasing a more land wherein we already have a problem of urbanization, climate changes, shrinking of the land, and all these things. And that's why we are saying that AI is not going to replace farmers in any way. It is going to help the farmers to make a better decision. See what smart farming actually looks like with our slide 4. Smart farming, making an agriculture decision using a real-time data instead of relying only on expertise or experiences. Let's look how the technology shown over here. The IoT soil sensors, what you are seeing over here on the slides, are buried underground, continuously measuring soil moisture, temperature, salinity, okay? And think of these sensors as your fitness trackers for the plant. Just as your smartwatch that monitors your heart rate, these sensors monitors the health of the soil. Do we able to create a connection between your AI and the agriculture? Sensors that we classified as an IoT devices or IoT sensors, that is Internet of Things. IoT stands for Internet of Things, and that's how in the agriculture we have an IoT soil sensors that are buried under the ground to continuously monitor or measure the soil moisture, temperature, and its salinity. Next, we have something called as drones and satellites. They capture images in the reveal of a crop stress before it becomes visible to a human eye. Okay, so robotic is another important technology where the modern robots can remove weed, harvest fruits, and even perform targeted spraying. Finally, we have an AI cloud system that combines a weather forecast, soil measurement, satellites images, and machinery data to recommend exactly when the farmer should integrate or irrigate, fertilize, or harvest. So the goal of these smart farming is simple: producing more food while using a very few natural resources that we have. So three things we have seen. We have seen an IoT sensors, robotic, and AI cloud system. These are the three more important, I can say, the most important pillars where we are, what I can say, facilitating in our modern farming. Okay, let me tell you. So the farmers usually water the entire field, right? So if we are using an AI, instead of watering the entire field, AI might recommend us watering only one section that is being drying out more when compared to section 2 or section 3. Let's suppose a farmer has a land or a field where it is being divided into three sections, section A, B, and C. So what AI would do is, instead of giving a water to the entire field having the section A, B, and C, it just recommend us to give a water to section B. That is what the section which is more drying out, because that is more exposed to sun. That might be the reason. So instead of watering to the entire field, we are only watering, or we are giving more priority to watering only to the section B. Now let's understand the technology that makes all these intelligent decisions possible. And that technology, we already know that it is nothing but AI. So how does AI works behind the scene? Now, artificial intelligence is a broad field focused on creating a system capable of performing tasks that normally requires human intelligence. This is what is a basic definition of artificial intelligence is. This field is going to focus on creating system capable of performing tasks that normally requires a human intelligence. So one domain we are learning about agriculture. AI could also be applied to what I can say, something called as medicine. AI could also be applied to something called as engineering field. So AI could apply to anything. That's why we are generalizing its definition, saying that it is a broader field where we focus on creating system capable of performing tasks that normally requires a human intelligence. And machine learning, you will also heard a word about machine learning, which is a subset of AI. Okay, so we will understand this in a way that instead of writing every rule manually, we provide examples on allowing our computers to learn based on patterns. Train our machine based on the pattern. This is what a machine learning or an artificial intelligence is. Machine learning is a subset or a part of AI. I'm going to give you an example related to agriculture. For example, if we wanted a computer to recognize a disease leaf, okay, here we are discussing about agriculture, so that's why I'm giving this example. If we wanted to recognize our computer that this particular leaf has a disease, we could write thousands of rules describing every possible disease. Right? There could be hundreds and thousands of ways to recognize a disease, what type of disease this is. If the leaf is going to be, it goes bad from the right corner, then what happens? It goes bad from the left corner, what happens? So what we are trying to say is we need to write 1,000 rules to make computer understand if it is going to look like this, and this is what a particular disease is. Instead of that, if we show the computer thousands or even the millions of images of the healthy and the diseased plant, the computer understand that if the leaf is going to look like this, then this is what this type of disease is. If the leaf looks like perfectly healthy, green in color, then this leaf does not have any disease. So instead of writing a manual program, we are imaging, or we are training our computer with the images to understand a difference between a healthy and a diseased plant is. Over the time, the computer learned to recognize the difference on its own. We will train the machine, like for example, we have a data of 100%. So we'll be training our machine for 80% and the rest 20% machine is going to deduct by itself. AI recognize over here in terms of agriculture, they understand what are the different type of insects that has, what are the different types of diseases that the leaf has, what the crop has a stress, does it have a weed, or does it is a good plant or it is a bad plant. And that's how it is happening. Same with respect to AI. Now let's examine a real world example where AI has transformed our agriculture. Moving to slide 6, if you see over here, John Deere is one of the world's largest manufacturers of agricultural machinery, but today it's also a leader in agricultural AI. Have you heard? Spray system uses a camera mounted along a spray boom to continuously capture images as a tractor moves through a field. So what is that they are doing? They are one of the largest AI manufacturing tractors also. What they are doing, they are using a camera mounted along a spraying boom to continuously capture images as a tractor moves through a field. The AI analyzes every image in a real time and asks one question. And what is that question? It says, is this a crop or a weed? If it is deducted as a weed, it is simply going to activate the tiny nozzle of the spray and then it is going to spray it. If it deduct as a crop, then it does nothing. It does not require any spraying. And all these happens in less than 50 milliseconds while the tractor is moving approximately 50 miles per hour. This system dramatically reduces the what I can say, the cost, minimizes the environmental impact while maintaining the crop yield. And this is the excellent example of computer vision solving a real problem. What's happening beneath the soil? Moving on to slide number 7, where we are going to see now. Imagine if a plant could send a farmer a message saying that I am thirsty. Is this possible? Is it possible because of sensors? It's not possible directly. Plants cannot message the farmer saying that I am thirsty. Since plants cannot communicate directly, we use sensors. And a crop X place sensors at a multiple depth where within the soil to measure its temperature, its moisture, and the electric conductivity. These measurements are transmitted to a cloud softwares and where AI combine them with the weather forecast, satellites imagery, and historical data. Instead of guessing when to irrigate and farmer receive a precise recommendation, this improves crop yield while reducing water waste and preventing diseases caused by overwatering. Think of this in a smart health monitoring system, but for crop instead of the people. So instead of imagining people in terms of smart health monitoring system, we are imagining crops. So with the help of these sensors, the farmers are getting the accurate precision of when does the field require watering without wastage of water, when does the field is what I can say the plants are going bad, what type of diseases those plants got, and what should be done in order to improve that particular kind of the situation. Now, so far we have looked successfully about the application of AI in agriculture. Now we will examine the startup that we have faced a significant engineering challenge and discuss how we are going to learn from these experiences. Moving on to slide number 8 that speaks about how these things could be possible. Now, so far we have looked some of the successful examples of AI agriculture such as John Deere and CropX. John Deere was the AI-enabled tractor that is going to spray based on if it finds a weed or a crop, and CropX is a sensor that is going to deduct us when does the field require watering. However, not every innovative idea succeed, and sometimes we have learned most of these project face challenges. This slides introduce to you about a Monarch tractor, where a company that sets out to build one of the world first fully electric AI-powered automated tractors. Their vision was exciting. Imagine a tractor that could operate with a little or no human intervention while reducing the emission and increasing the efficiency. But unfortunately, moving from a great idea to a reliable product provide difficulties. The dealer reported issues such as an unexpected power loss, equipped failures, and inconsistent autonomous performance. These challenges affected customers' confidence and eventually forced the company to restructure. Later, a caterpillar acquired many of the monarch's intellectual property assets. So this slide speaks that yes, AI in agriculture or modern farming could help, but everybody who is trying to do so did not receive success. Few of them has faced challenges as well. The success was the success stories that we have discussed about John Deere and CropX. But however, on the other hand, Monarch Tractor also introduced the same idea in order to provide efficiency, but was not able to succeed. Later, another company called as Caterpillar that acquired the information about the what I can say intellectual property of Monarch Intellect. Now, the most important lesson that we learn from this particular slide is AI does not guarantee success. A complete engineering system that requires a reliable hardware, a robust software, a safety mechanism, maintenance planning, and extensive field testing is required. Agricultural machinery operates on one of the most harshest environmental imaginable. Equipment must be within the standard dust, rain, extreme temperature, vibrations, and long hours of continuous operation. Even an excellent AI model cannot compensate for unreliable hardware. So, as we know, the nature of the agriculture itself is a very harsh environment. So, the equipment must be in a stand to what I can say, pass the dust, rain, extreme temperature, extreme weather condition, long working hours. So the engineering part is also plays an important role. Another lesson is that software often becomes more valuable than hardware. While manufacturing machinery is expensive, software platforms can be licensed to many of the manufacturers, making them more scalable. So a successful AI system requires a strong engineering, not just a good algorithm. That's the key takeaway from this particular slide. So a successful AI implementation does also requires a strong engineering. Now we will discuss about engineering challenges, and let's shift our focus to one of our biggest goal of a modern agriculture, that is called as sustainability. Moving on, when people hear the phrase produce from food, many assumes we simply need more farmland. However, expanding farmland, we have seen in the last slides as well, often means cutting down forests, destroying wildlife habitats, and increasing the carbon emission. Instead of expanding the outward or the modern agriculture focus on producing more food from the existing farmland through the smart management. And this approach is called as sustainability. Now, artificial intelligence plays a main role in this goal. AI help farmers identifying exactly when does water is needed, whether or where fertilizers should be applied, and where diseases is being or beginning to spread. Instead of treating the entire field uniformly, AI support precision agriculture. Conservation agriculture is another important concept where what I can say practices such as crop rotation, compositions, or composting, reducing the moisture, conservation, improving of the soil health while protecting the environment. The slide also highlights the several exciting STEM career where we are talking about remote sensing scientists that analyzes the satellites and drone imagery. agronomic AI engineers that develop intelligent farming system, bioinformatic researchers that study plants to develop crop that are more resistant to heat as well as diseases. These careers demonstrate that agriculture today combines with biology, engineering, data science, as well as artificial intelligence. Let's just quickly explore this particular slide and then we can move forward. Okay. So here are some we have a list of what I can say. There are three steps where in the first step you will list what do you use an AI application, any five application, be it be a chat GPT, Google Map, Netflix, anything. Okay. Then the step two is going to be something called as you are designing a technology for a farmer. Okay, you yourself are trying to design technology for farmer for their easy use. Okay, anything that you think of these application and how they can help in an agriculture. Chat GPT, how it will help in agriculture. Face recognition, how it will help in agriculture. Netflix recommendation, how does it helps in agriculture? Right? Then in step three, you're going to speak about what you thought of, which particular, AI application that you thought in the first step, and how you are relating this into step two.
So, ma'am, I usually do this whenever I see any different type of plant because I'm much interested in botany. So we can use the Google Lens because usually use this. So we can use the Google Lens for identifying the crop diseases by scanning it because it can easily scan and share us. And also we have one weather app which we all have used in our life, so we can use that app as AI, like predicting the weather and recommending which month to sowing the seed or for harvesting. And for we have Amazon also or other Flipkart options, so we can use some tools or some seeds to buy for our production. So that's all from my side.
Please go ahead.
Yeah, I believe AI can also help overcoming language barriers among farmers. Like if chemical treatment labels or machinery manuals are written in a foreign language, then for that AI can be used and it can be helpful for farmers, especially.
Yes, yes, absolutely. Absolutely. Very good point.
Uh, I would like to add an idea of my own. So, leguminous plants like soybean and pea have a major growth factor, that is the growth of root nodules and nitrogen fixation going on in their roots. So, if we can use AI to check on the nitrogen fixation or the growth of root nodules, we can help the leguminous plants to grow better or efficiently.
Okay. Yes, that's true. Yes, that's also one of the most important factor for using an AI in smart farming. I can be facilitating or the day-to-day applications or the technologies that we are using in terms of AI could help in an agriculture or in smart farming. Moving on to our next slide, that is slide number 11. If you see the difference between which is marked in red and green color, so this slide introduced one of the biggest changes in computer sciences. Okay, where the traditional software often offers or call that as software 1.0 that depends on programmers writing explicit rules. For example, if I'm giving you an example in terms of agricultural smart farming, if the leaf is yellow and humidity is above 80%, then spray. Okay, spray any of these fungicides, I can say, or bacterial infection that sprays that is available. So what rule we have said? We said that if the leaf is yellow in color and the humidity is above 80%, then you need to spray a fungicide. This approach works very well if the situations are very simple. However, the farming itself is very highly unpredictable, what I can say, a factor where there will be even a slight changes, then this rule is not going to work. Like, for example, if there is a change in the lightning throughout the day, if the weather condition varies, if it is cloudy, right? Leaf may have a different color than yellow, or leaf may have different shapes. So writing these rules for every small minute details certainly become impossible. So a machine learning and a software called as 2.0 that solve these problems differently. Instead of writing these rules where we need to provide thousands or even millions of examples where we are training our machines to learn by pattern. And this computer identify patterns based on their built-in mathematical models. Right? So a machine learning allows computer to learn from a data instead of relying entirely on a human written instructions. That is what a general definition of machine learning is. We have seen a general definition of AI is, and this is a general definition of machine learning where it allows computers to learn from a data instead of solely relying on a human written instructions or programs. Then in our next upcoming slides, we will see the important AI model that we are using for image recognition and how they are going to help in our modern farming. We'll continue from slide 12 in our next week class, and we will end our session for this particular workshop today.